have from homework stuff? You guys all right out there? Have you guys, I graded a lot of stuff from all my classes. I've been going crazy. All right. What I want to do then, if no one has questions, we're gonna go back into the last chapter we did, and we're gonna do some more from that section. Let me see. Let me do this. There we go. Oh, okay. That's going to be a little annoying, but oh well. Hold on, sorry. I'm letting somebody in. Come on, come in, come in. Oh, you guys have got to get here on time. Okay. All right, so everybody who just joined, let me see. You can't hear me yet. Come on, audio, connect. Come on, you can do it. All right, she still can't hear me. All right, there we go. So, Amon, you're okay because your name is pretty unique. The three people just came in. You missed the whole thing. I'm going to be a little bit more careful about security because last night I had somebody come into the class that was uninvited. It was nowhere near as bad as it could have been. I very quickly kicked them out, but I'm going to be a little more careful with security. So when you log in, I do need your whole name to show up, your first name, your last name. And then anybody who does not have that, I will just make them go away. All right, especially if they're not a name that's in my class. Okay, anybody questions before I get back into going back over what we just did last time? All right, so let's do this. So let's do this. So last time we did some weird shit with percentages. So today we're gonna do some weird shit with, weird stuff with Starbucks. Why not? So what do I mean by that? All right, so first thing I gotta do. Oh no, somebody left. Let me see.
Bluetooth.
Oh crappity, dude. Hold on. Christian Ray, okay. All right, that's not too bad. All right. Can somebody do me a favor? Say something. Anybody say anything? Somebody say something.
Something.
Good. Thank you. All right. Thank you. You follow directions very well. I just want to make sure because my speakers have been having trouble connecting sometimes. All right. So look at this. We're back in section 1.3. We're going to look at these problems here. I like this first problem because it's relatively simple, but it's not immediately simple. Let's see what I mean. This is the author speaking, by the way, because I sure as all hell do some coffee, right? So let's see. Oh, here's somebody else.
What page is that?
36. I like it. And real quick, Raji, can you put, well, let's see. You're fine. All right. I like it. Okay. All right. So a venti cup. Does anyone go to Starbucks? Anybody?
Yes.
All right. I also go to Starbucks sometimes, but I have to be very honest. If I go to Einstein Bagel or something, it's so nice to be able to just say freaking medium. All right, I'm done. That's my old man moment of the day right there. I want a medium coffee. So a venti cup costs $2.45. Suppose somebody buys 2 of those every day. How much would she spend in 1 full year? Dude. So what do we have to know to be able to do this?
mean, you're gonna need to know how many days there are in the year.
Good. So how many days in a year are there?
365.
Good. Except for when?
Leap year.
Leap
Leap year. So we're going to assume it's not a leap year, else they would have said so. I like it. So go ahead and try to do this problem. You should have everything you need to know. If you're not sure what to do, do something, and then I'll do it with you in a minute. So they buy 2 cups of coffee, $2.45 each, every day for a year. How much total money would that be? Don't say anything, just work on it. I'm going to turn my heater off. Right, here's somebody. Uh-oh, here comes a chat. Oh, okay, somebody's got the answer. I like it. Hold on, let's find out. Hold on to that answer. So some of you guys, I want you to really understand what I mean on your homework when I say show work, right? If by this point you haven't picked up on the fact that work is very important to me, I don't know what to do. I've got a shirt that says show your work, right? I put it on my syllabus. When I say show work, I don't mean do the long multiplication or something. I mean, tell me what it is that you're putting in the calculator. So can somebody tell me what it is you would put in the calculator to do this?
2 times 2.45.
It's a good start.
So yeah, and
And
then
then times 365.
I like it. So 2 cups, each cup is $2.45. That's a day's worth of coffee times 365 days. I love it. Is everybody cool with that? So that's the work. That's showing me the work. And then you throw that in the old calculator. I'm not going to make you do long multiplication for every problem. My God. And I think somebody already told me what this was. Let me see if it makes sense. It should be on the order of 1,500 to 2,000.
1788.50.
1788 point
5.50.
50.
Yes.
Is that what everybody else got? Yeah. I think you can see what you did. The one person who told me something else, right? Okay. I like it. Is everybody cool with that so far? That wasn't too horrible. Okay. All right. So you're going to see problems in the homework that are basically the same as this, right? So they do so much per week for 16 weeks. How much overall? It's a bunch of multiplications, right? Now, where are they getting this 490? Where's the 490 coming from in part 6?
The 245 times 2.
Exactly. So if they say this is 1 day's worth of coffee, right? So if you wanted to do this using addition, you would have to write 490. Of course, how many times? You would write 490 plus 490 plus 490. How many times?
365.
365 times, right? But instead, what did we decided to do? We decided to do this 4.90 multiply 4.90 by 365. So now this is kind of silly. Just go with me. 490, Jeff, how the mighty have fallen. Hold on. 490 plus 490 plus 490. Let me write this 365 times. Just hold on. I'm joking. Good Lord. Can you imagine? So that's, or I could just write 365 times 4.90, right? Of course, we should all know that, but they are going to ask this kind of question in the homework. And I want you to realize, whoa, what happened to the person? Dadgummit. There she is. Okay. Oh, this waiting room thing sucks, but oh well. Okay. So pretty cool with that. That's very, very straightforward. That's basically the definition of multiplication. All right. So let me see. Is the rest of this any good at all? I'm going to clear what I've written. Everybody ready? I'm going to clear all this away. I think somebody just came in, but all right, I'm going to clear this away. Here it goes. It's gone now. Okay. All right, let's see now. Let's do these two problems right here. What about do number 8 real quick? Right, so if she buys two 245 cups, that's 490, right? Obviously, how much will she spend after one day?
490.
490, right? We know she spends $4.90 a day on coffee, right? After 3 days, what would I do?
490 times 3.
Times it by
Take it.
3.
Yeah. So 3 times 490. I could also do 490 plus 490 plus 490. Of course, we know those mean the same thing, but why would I do that? And what do you get? There's trying to be a 9 there. What do you get when you do that? 1470? 1470? Help me out, guys. What do you get when you do that?
1470.
1470. Thank you. So, okay, 10 days, 180 days, easy enough, right? That's pretty straightforward. But again, you're going to see basically the same kind of question in the homework. I just want you to see what they really want from you. It is this simple. It is this basic, right? Now, number 9, I like number 9 a lot. I would. So just try out number 9. So remember, how much did she at Starbucks? How much did she spend in a year? Did somebody remember that? What was the answer we got earlier? In a year, how much was she spending at Starbucks?
$1,788.50.
All right, good. You're going to need that number. Now, what if instead she goes to the neighborhood 7-Eleven or whatever it is and gets the $1.49 coffee? Right. Where am I? Any of you consider yourselves coffee snobs? Do you know what that means? Are any of you coffee snobs?
Kind of.
Okay.
I only have 1 cup a day though.
Understood. I have a friend who lives, surprise, surprise, in Seattle. And she is a complete coffee snob. I am not really a coffee snob, right? But anyway, that's enough of that. Can you guys figure out how much would she save for a year if she didn't go to Starbucks, but instead she went to 7-Eleven, which coffee
So-
snobs probably would explode. Don't say anything yet. Hold on.
Oh,
Everybody,
okay.
Let everybody try it real quick. Let me see. You could privately message me. And to be honest, I don't know. I haven't done this yet, so I don't know. Let's see if you could do it real quick, Jeff. Don't forget, how many cups is she buying a day? How many cups is she buying each day?
Fine, 2.
Two cups. 2 cups. So how much is she spending each day at the convenience store?
490.
No. That's at Starbucks. How much is she spending at the convenience store for number 9?
298.
298. Right? She's getting 2 cups and they cost $1.49 each. Is everybody with me? So then you're one step away. What do you do to figure out how much it costs for a full year at the convenience store. What do you do?
Multiply 365.
Yeah, so take the 298 per day times 365 days. And what does that come out to be?
$1,087.70.
1,087?
$1,087.70.
Like that. Okay.
Like-
Thank you. So then what's the answer?
$700.80.
Yeah, you got it. So somebody got it way early. Good job, guys. So $700. So you just subtract these two, right? She could save $700.80. And a lot of us would say, it's worth it, man. Are you kidding me? Why would I buy that brown water from the convenience store? I understand, right? Okay. Does anyone see anything we've done that didn't make sense why we did it? That's the important question. So whenever we're doing stuff together, the specific thing we're doing almost doesn't matter. It's all about why am I doing what I'm doing? What is it in the problem that showed me I needed to do what I did? Right? Because I am never going to ask you this exact question ever. I already did. We already did it. Why would I ask you this question again? I'm going to ask you questions like this. So you have to know, what do I look for to tell me what to do? Right? All right. I like it. I like it. All right. I'm going to clear all this away. Here we go. You ready? I'm going to clear all this away. Here it goes. It's gone. Yeah, now let's look at this. This is getting more interesting. Oh God, really? All right, I don't know if you guys get the reference here. Tommy and Gina plan to start saving for retirement. They put $1,000 into an account to start out. They're going to deposit $100 each month for the next 20 years. How much money will they have in the account at the end of 20 years? Go ahead, try it, do it. Don't say anything out loud. Don't type anything to everybody. Just try it. Uh-oh, is somebody already done with it? Oh, could be. Does anyone get that reference, by the way? I don't know.
Yes, I do.
You do, okay.
He would only have 2,000, right?
Say again, sorry?
2,000 in the bank.
Well, let's see now.
100 times 365.
Wait. Did they put $100 each day?
No, they
Each month.
plan
$100 each month for,
yeah.
for 20
Then you
years.
times it by
So $100
mhm,
each month. So what I'm going to multiply that by?
by 20.
Well, that's 20 years, but what's the each month piece?
12.
100 times 12.
12.
There.
100.
$100 each month, so times
Yeah.
12.
Yeah.
So this is a year now, times 20 years. And now this is the total. Now, why is this by itself not the answer once I do that?
That's the total amount of time.
You need
No,
to
this
add
is
the
not going to be
amount.
time. This is going to be money.
24. 24,000.
1,000.
Total amount of time. That's what I
All right. So I love you guys so much. So 24,000,
24,000. Yeah.
but that's not the answer. Why not?
You have to add the $1,000 deposit.
Yeah.
Yeah. So plus 1,000, 25,000. Oh crap. I love when my pen does that. Hold on. Pen. My pen gets all excited. Stop it. Okay. All right, now listen. I'm going to say this every now and again. I don't think I've said this very much yet. You all have very, very, very different math backgrounds. Some of you guys are sitting there going, oh my God, this is so easy. Enjoy it. Enjoy it. enjoy it if it's easy. Enjoy it, because it's not going to stay that way forever. If this is not easy, if you're not sure where something's coming from, speak up, right? Don't be afraid. You can private message me as always. If you have a question and you don't feel like sharing it with people, that's fine. I understand. But screw them. If somebody's giving you issues because you're asking questions, screw them. You're the one paying for your education. Does that make everybody with me?
Yeah.
Yeah. So I don't take kindly to anyone making fun of anyone else for any question they ask. I really don't like that shit. So don't do that. So please don't hesitate to speak up if you have any question about where anything came from. All right. Blah, 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 blah. So this is the same kind of problem again, like we did earlier with the coffee. Let's see what they talk about here. Connie and Gina, they stick with the plan of $100 each month. Yeah, let's try this out. I like this. Go ahead and fill out this chart here. This really gives it away. If you didn't get that reference, I don't know. Oh, we're halfway there. Oh. Whoa. So who's got after 1 month? This is nice. How much money will they have in there after 1 month?
$1,100.
Yeah, so 1,000. Oh, crappity doodah. Come on, Pen. 1,000 plus one $100 payment, right? So that's $1,100.
Mm-hmm.
I like it. Some people are chatting me. There you go. $1,100. Yeah. After 1 year, what calculations am I doing? They have put the $1,000 plus. What do I put now?
12.
12 months in a year times.
100.
I like it. So what's that come out to be?
2,200.
2,200. Kick ass. So what do I put here for 5 years?
60.
I like it. So 5 times 12, 5 years, 12 months every year, $100 payments every month. So it'll be 1,000 plus 6,000, 7,000. Let me put some units on these things. Give me some units. Oh, somebody's chatting at me. I like it. I'm going to do something crazy in a minute. Oh, it's going to be so crazy. All right. Oh shit, somebody left. So 1,000 for 10 years, of course, what would I put instead compared to what I put here? What calculation do I do? Anybody?
The 10 times 12.
Good. 10 years, 12 years in 12 months in a year, $100 each month. This would be 1,000 plus 12,000. And that, of course, is 13,000. Now watch, I'm going to go crazy. What if I put one more thing here? After T years. So I want to know how much money do they have after T years? Oh shit, I'm cranking up the algebra. Watch out. What did I do when it was 5 years? I did 1,000 plus 5 times 12 times 100. What did I do when there was 10 years? 1,000 plus 10 times 12 times 100. So what do I do if it's T years?
Just add
1,000
1,000 to it.
plus T times 12.
1,000
100.
plus. Good. So let me just write it like this. I like it. T times 12 times 100, which would be 1,000 plus 1,200 T. That would be an equation that would tell me after so many years. That would make all this other stuff quicker, wouldn't it? Right? That's the purpose of equations, is to make it quicker to do stuff. So let's check this equation out. I don't know. Is anybody having trouble with this equation? Are you guys okay with this equation? Right? When it was 5 years, it's 5 times 12 times 100. 10 years, 10 times 12 times 100. Some unknown number of T years, T times 12 times 100. That's all algebra does, is it says, oh, there's a pattern. Oh, cool. Yes, let's use the pattern. That's all it does. So if I use that equation for 5 years, the equation says 1,000 plus 1,200 times 5, right? What's 1,200 times 5?
$6,000.
6,000.
6,000. And I get 7,000, which of course is exactly what we got earlier, right? For 5 years. Okay, so I'm trying to get us, some of us just need to believe in equations a little more, right? They exist for a purpose. They exist to capture the idea of what to do if I just knew, in this case, how many years, right? So it wants to write down what to do if I don't know how many years. And then I can plug whatever number of years I want to in there. Okay, okay. All right, let me see if I can push my luck a little bit. What would I do then for 1 month? Does anyone know what I would put in for T if it was 1 month?
The T would be 1.
No, because the T represents number of years, doesn't it? Be very careful.
Kim?
So 1 month is 1 month. Somebody's got the answer. I like it. Thank you.
Kim?
1 month, is it a full year?
No,
Of course not. What fractional part of a year is it? 1
1
month
over
out
12.
of, sorry?
1/12.
1 over
Yes,
12.
it's 1/12 of a year, isn't it? I really want this to make sense. Since it takes 12 months to make a year, 1 month is 1 out of 12 of what I need. So it's 1/12 of a year. All right, I'm really
that
pushing
would
this.
be 30 days, 31 days.
Wait, no. Nothing to do about days,
Oh, okay.
right? I didn't bring days in it. Why would days make this really, really weird? Why are days weird when I'm talking about months and years?
Because it's different.
Each month is
Yeah.
different.
Some months have 30 and some months have 31 and some months have 28 and sometimes 29 and holy shit.
Yeah.
Right. So yeah, let's not bring days into this along with months. Yeah. So 1 month is 1/12 of a year. Now, why does that make sense? What would 2 months be then? What fractional part of a year?
2/12.
2/12 of a year. So what would 12 months be?
1.
12/12, 1 year. Let that make sense, right?
Yeah.
1 month is 1/12 of a year because it takes 12 of them to make a full year. All right. Wow, I am milking this problem, dude. So if some of you guys are like, what does this have to do with number 11 in the book? It's got nothing to do with it. This is just me going off, riffing on math. Right? Okay. Sorry. I'm sorry. I'm doing some improvisational jazz math.
Being a
All right, I'm going to erase all this in a minute. Let me see. I think some of you guys are still copying down. All right. Yeah. So will everything I just did with the T and the 1/12 and all that, will that help you with this homework? Maybe not. I don't care. It will help you in general. That's what matters to me. This homework is a little easier than the T stuff we just did, right? So I just went a little further. I'm going to clear all this away. Here it goes. Oh shit, somebody's coming in. All right, it's all gone. It's gone now. All right, and then this is what we did yesterday right here. Remember this? This was exciting. I really, really hope that this makes more sense now. Okay, all right. So we finished all this. Let's see, I think we did. Did we do all this? Yes, we did. I like it. Yay. So a little bit of a preview, and then I'm going to end the class a little early today because I got a meeting I have to get ready for, but let's see. Oh, so this homework is going to have a couple of problems that should be relatively easy. One thing I want to say about number one, if you haven't tried this problem yet, if you read through this, if you spend 30 minutes a day goofing off, how much study time will you waste over the course of a 16-week semester? What if you waste 45 minutes a day? You assume they mean every day, so a full 7 days. Are you guys with me? You assume that it's 30 minutes and 45 minutes every day, so 7 days a week. 7 days a week. Okay. And then you have very similar problems down here. It's a bunch of do I multiply, do I add kind of questions. These visual questions are very interesting. I need you to just try them out. They talk about why area is square stuff and why volume is cubic stuff. I love these kind of problems to visually show you why that's true. All right. Now let's talk about this. We talk about exponents. So in the next section, in section 1.4, we're going to be working with exponents. We're going to be working with repeated multiplication stuff, which is what exponents are, right? They finally talk about order of operations. And I like the way they do this. Remember multiplication, division on the same level, right? So if you ever had a teacher that told you multiplication always comes before division, take a snapshot of this page, send it to them and say, you should know what you're talking about before you talk about it, right? Okay, thank you very much. Public service announcement. How about this guy? Let's talk about this guy for a minute. Distributive property, right? Why the hell does that work? This should kind of piss you guys off a little bit. So let's do this step by step. If I have this problem right here, what does order of operations say you must do first?
Add.
The
Yes,
parentheses.
so you have to do inside the parentheses. So then you would get 4 times 5, which is 20. Is that cool?
Yeah.
Now, stay with me now. This is where things get interesting. All right, so that's fine. That's beautiful. That's fantastic. That's fine. What does 4 times something mean? This is a weird question, I know, but what does 4 times x actually mean?
Means 4 times a number unknown.
Okay.
That's
all
me,
right.
something plus something plus something
There
plus
you
something
go.
4 times.
It means something added to itself 4 times. All right, let me stop for a minute. Is everybody cool with that? That's basically what we started today with, was multiplication is repeated addition. Okay, I like it. So now watch this shit. I mean stuff, sorry. 4 times 2 plus 3. This is a very crazy way to do this. What this means then is I have 4 of these. I have 2 plus 3 plus 2 plus 3 plus 2 plus 3 plus 2 plus 3. I have 4, right? Doesn't 4 times x mean x plus x plus x plus x? So 4 times 2 plus 3 means 2 plus 3 plus 2 plus 3 plus 2 plus 3 plus 2 plus 3. How many 2s do I have?
8 or 4.
So that's 4 times 2. And how many 3s do I have, of course?
4.
4. So that's where distribution comes from. It's a shortcut. 4 times 2 plus 4 times 3. That's why it's called distributive property. Now, please, dear God, listen to me. Listen. You only do this kind of thing for this problem if they tell you to. Otherwise, I am doing this. Of course I am, right? Of course I'm going to do this. Look how quick that is. That's beautiful. But I want you to understand why distribution is allowed. All right, now watch. Let me show you another example. So of course I get the same answer here, right? This would be 8 plus 12, which is 20, which is the same answer, right? Same answer we got earlier. Of course it is. Is there a situation, and let me just give it to you. What about this situation? Can you do what the order operations wants you to do in this problem?
No,
Why not?
because it's two separate.
What would
exponents.
order operations want you to do first?
Parentheses.
Multiply.
Parentheses. Can you do x plus 3? Can you do that?
No.
Yes.
No.
Yes, 3.
No.
No,
Wait. Whoa, wait. I'm really excited now. How do you do x plus 3?
you can't.
X plus 3.
Okay, good. You
It's x plus
cannot. So if you go strictly by the way it's written, you cannot do this. So why do we do something? How do we do something? Because what we do is we rewrite this. Order operation says you can't do shit, Jack. And we're like, okay, let me rewrite it like this. I got 1, 2, 3, 4 x plus 3s, right? 1, 2, 3, 4 x plus 3. Now I got 4 x's and 4 3s. Now, this middle work, we never do now because we understand that it's a shortcut. The middle work you never do because now the shortcut is 4 times x plus 4 times 3, 4x plus 12. So distributive property is a shortcut. It's not going against order operations. It's just rewriting the problem so I'm legally able to do it, right? And I know this is overanalyzing for some of you guys. Some of you guys are like, of course you just distribute, Jeff. What the shit's all that? But I want everybody to really understand why we're allowed to break order operations. We don't. We're not. It's just a shortcut about all the stuff we had to do to make it so we could do something. All right, that was probably a deeper dive than anybody wanted, but that's all right. All right, guys. So this is our first, and don't get too excited. This won't be every day now, but we're basically going to end class now. I think at least one person needs to hang out for a little bit. Otherwise, you are free to go. Believe it or not, you are free to go, and I will see you tomorrow. Let me know if you need to hang out for a bit. Otherwise, fly, be free.
Thank you.
You're welcome.